Hi all, this is Mr. Yeager for chemistry. We are starting our first of many gas laws, okay? And with each of these, you need to be able to remember the name, what quantities it relates to each other, okay? We're going to be looking at things like pressure, volume, and temperature. And we need to know the relationship between those two quantities. We should try to really kind of think of it qualitatively in the sense of, you know, you should be able to kind of use more common sense of if I start pushing it, what should happen to the volume, etc. All right. But we will be looking at the relationships, and then we have formulas with each of these that we're going to be doing. So we start off with Boyles Law always. Okay, for whatever reason. I don't know why we always start off with Boyles. Okay. But Boyles Law, he relates volume and pressure. All right. So Boyle is volume and pressure. All right, is what we got with it. And with these two things, volume and pressure are inversely related. Sometimes we say indirectly related. That just means that as one goes up, the other goes down. All right, which again, hopefully, this little example I was kind of giving at the beginning, if you push something, if you push a balloon, what happens? You're trying to decrease the volume. The piston example from the video in the intro, okay, the intro to gas video. The piston is decreasing the volume. What happens inside of that container? You increase the pressure. So volume and pressure are inversely related with Boyle's law. All right, so here's your piston. I mean, there you go. If I push down, I'm decreasing the volume, which increases the pressure because the particles hit on the side. Another example we have with it would be growing and shrinking marshmallows. That would be the whole idea of if we're able to actually pull air out of a system, you'd actually see that marshmallow increase because you're decreasing the pressure, or increase as you go more with it. All right? There are other examples as well. We're not watching the video. Come on. Okay? So Boyle's Law, created by Robert Boyle. Our formula for it is simply P1V1 equals P2V2. All right? And again, you'll be given these formulas. It looks like a lot of different formulas, but again, you read the problem and go, what are the things that I have in my problem? What am I using? Okay, what am I trying to change? So P1V1 equals P2V2. Okay, pressure units and volume units must match. So we do have to pay attention to that. There might be some slight times where we have to like convert one thing to another, but you know, you have to be ready for that. All right, you also need to remember standard temperature and pressure. Okay. Standard temperature and pressure. The problem might just be like you're at this pressure and this volume, or sorry, this pressure and this volume, and then you switch to STP. You just need to remember you need to change over to 1 atm. The temperature doesn't matter. I should go back and say, with Boyle's Law, let's actually point that out real fast. With Boyle's Law, we are changing volume and pressure. Temperature is constant. So we are changing this situation. We are messing with the pressure and volume without changing the temperature. I guess it does say that very clearly right there. We are, and the mass. Okay, we don't get too much in the mass in on-level chemistry, but we would have to obviously keep the mass the same as well. Okay, all right. So I think we're going to get to some problems. Oh, sorry. One other thing just to kind of be able to recognize is the graphs, okay? If I make a Boyle's Law graph, which would be pressure and volume, you should see that line going down, okay? I'm not too worried about you understanding that it's a curve, okay? It should be because it's a inverse relationship, 1 over x relationship, which would be a curve going downward, all right? But it's going to be actually the only one out of our different gas laws which decreases, okay? All the other two that we're going to be doing, well, we have 4 more to do, but 2 others with names, they will have graphs that go up. Okay, so let's try a couple problems here. So it says converted pressure of 209. Oh, okay, sorry. This is just making us do conversions real fast. So let's, I guess, do this. Let's convert 291.4 millimeters of mercury to torr and atmospheres. Well, our conversion is 1 atm equals 760 millimeters of mercury, which equals 760 torr. So that means millimeters of mercury and torr are the same thing. So your answer for 291 to torr is 291.4 torr. So you don't have to do anything there. Now for atmospheres, we would have to just do a quick dimensional analysis. 291.4 millimeters of mercury. Again, just like we did with stoichiometry or mole calculations, I come from millimeters of mercury, I'm going to ATM. All of these should be one-step problems. I copy down the constants in front, 1 and 760, and then I convert. 291.4 divided by 760. This is 0.3834 ATM. Okay. All right, one more. Convert 0.758 ATMs to millimeters mercury and torr. I only need to do it once because, again, millimeters of mercury and torr are going to be the same thing. So 0.75 ATM. This time I'm putting ATM on the bottom because that's what I'm coming from, going to millimeters of mercury. 760 is now on top, 1 ATM, 0.75 times 760. I'm getting 570 millimeters of mercury, which is the same thing as torr. Okay. All right, they make me do another one, I'm skipping it. There you go. All right, so let's actually get to Boyles Law. A gas at 25 degrees Celsius has a volume of 335 milliliters and a pressure of 1.01 ATM. If the pressure of this gas is increased to 1.35 ATM, what is the new volume? All right, so I know I'm using Boyles because eventually all of these things are going to get mixed up with all the other gas laws, okay? I'm using Boyles because I'm being given a volume and a pressure, and I'm changing the pressure, and I want the new volume. This 25 degrees temperature, I don't care about. I don't need that at all. My formula is P1V1 equals P2V2. So, what is my pressure and volume initially? My pressure is 1.01 times 335. I do not need to change milliliters because that's what I'm solving for. It just means my answer will be in milliliters. And then my pressure units are the same, ATM and ATM, so I can leave that 1.35 times V2. Basically, all I'm doing is I'm going to divide the 1.35 that's alone over to the other side. So 1.01 times 335 divided by 1.35. My volume, my new volume, and think about what's happening. My pressure is increasing, which means my volume should decrease. Look at that. It decreased. It decreased to 200 and, sorry, I'm getting sig figs, 51 milliliters. The pressure increased, the volume decreased. All right, we're going to do basically just two more. All right, a gas at 32 degrees has a volume of 3 liters and a pressure of 0.98. If the pressure of this gas is decreased to 0.9, then what is the new volume? So once again, I have two pressures and I want two volumes. The temperature doesn't matter. P1V1 equals P2V2. I'm starting with 3 liters at 0.98. That's the only other area people will mess up on is they don't match up the right numbers. 0.98 is being multiplied by 3. My final pressure is 0.9, and I want V2. Divide by 0.9. So 0.98 times 3 divided by 0.9. V2 is equal to 3.3 liters. Again, does that make sense? My pressure is going down, which means my volume must go up. All right, one more. A 4-liter sample of gas originally at 782 torr has the pressure decreased to 741 torr. I don't know why we're solving for volume over and over again, but it doesn't matter. I mean, if you had to solve for pressure, I'd give you another volume. Okay? So, this one we don't even have to deal with any temperature. And I'm in torr, but that's fine. Leave it. They're both in torr. So we got P1V1 equals P2V2. I got P1 is 782 times 4 equals 741 times V2. Divide by 741. 782 times 4. Divide by 741. V2, 36 figs, 4.22. What am I? Liters. So just make sure you get that right unit with it. But that's it. That's Boyles Law. Okay? So just using the formula correctly so far. Again, we're going to be adding some more formulas, 4 more actually. So we use this one when we're playing with pressure and volume. And that's it. Thank you.